Hello everyone. Let's look at doing smart contracts in Rust, and let's look at using Soroban, Soroban SDK for the Stellar blockchain. Now you can look at others. I mean, you've got Solana and various others which also use a flavor of Rust or a subset of Rust, I would say. So if we look right at the top, we've got no underscore stud. So it leaves out a lot of this, or most of the standard library. Instead, you use the Soroban SDK, which has got its own vec, string, etc. It's got something called a symbol as well. So you've got a symbol, which is basically text, and you've got up to 9 characters, which is a short symbol, or over 9 characters, which is a normal symbol. So we are creating enum struct impl. So your contract is an impl attached to the struct, which is the name of the contract. And yeah, I'm still learning this, so give me some yes, give me some slack. But this is typical of a kind of an intro contract. Once you get beyond the increment example, which you will see everywhere. Nothing wrong with the increment example, but once you've seen it on about 5 different beginners tutorials, you want to just progress slightly beyond that. So what I thought I'd do today is just show what I've learned on top of the basic tutorials. One thing I want to mention is actually the constructor, which is new with Soroban 22, version 22. So you've got double underscore constructor, which is actually not something you would typically see in Rust. You might see it in Python, something like that. But it's initializing some values when the contract is initialized. If you don't do that, it will happen anyway, but it will be just initialized with no options. Or so where did I learn this? Sorry, shameless plug for my site, Red and Green. I learned it from Discord, and if you come onto Discord and go to, well, you'll need to add Stellar. So Stellar developers, and then you've got Stellar help, which is basically a sort of a chat bot which you can ask questions to, just if you want to confirm your understanding. So here's where I was asking it about the constructor. So I searched documentation. I pasted documentation into ChatGPT. That gave me one version of events, and then I just put it back into Stellar to confirm that that's what the case was. So the default constructor case. Sorry, I just adjusted the microphone. I will get a better microphone soon. I'm just in limbo a bit at the moment. Right. So contracts created with protocol 22 and later. Um, Contracts that don't explicitly define a constructor. So what am I on about here? Double underscore constructor, and then we're passing env, which you always use, and then value i32. So when if you need initialization with arguments, you'll need to explicitly define a constructor. That is constructors. Um, uh, if you come to Stellar Protocol Core, this was the preamble summary working group, which was done 3 months ago, and you can read all about it here. So yeah, I just wanted to cover constructors because I was just had a question in my head. And for Wasm with Soroban environment 22 or greater, the constructor is treated as a constructor function. The default constructor, so basically the semantics of the contracts that don't have a constructor, those created before Protocol 22, those that simply don't have a constructor defined, can significantly be simplified by treating them as having a default constructor with no arguments. So that is I just wanted to kind of show Discord how useful it is, using it more and more. I expect everyone else. No, I'm probably like the last one to the party here, but yeah. Anyway, let's look at what I've documented. So with a bit of help from ChatGPT, from Discord, from the Stellar examples. Uh, Let me just wind back. So I looked at the time lock example. I thought that I was getting a bit ahead of myself. So then I went and looked. I started looking at kind of the nitty gritty, and I wanted to know what bytes n is. So bytes n is basically um, a fixed length 32 bytes array. It's where you specify the length of the bytes array. So there, bytes n 32. You could put in 16, 64, and so on. This actually, so again, here you've got the struct, which is the name of the contract, and you do an import for that. So really, this is kind of like the name of it. And typically, you won't. I don't know if you ever actually see any key value pairs for that. I'm still learning this, so right. So there you got set data, get data. Set and get is very, very common. So they're public. So not everything has to be public, and you always pass in the env, capital E, because that's what you get with Soroban SDK. Then you just create your own variable, which is of type env, and then you pass that around, or you borrow it. Yeah, so lots of ampersands, lots of borrows, and yeah, lower down you got the tests here. So mod tests, which is your own test module, which you can either keep inside your lib.rs. So Soroban uses lib.rs rather than main.rs. And yeah, the tests actually can use all of Rust. So the smart contracts, because they get compiled to Wasm, use like the Soroban SDK in a subset of the Rust standard library. Check if the retrieved data is equal to the original data. So you're getting some data, and basically the set data, get data. So you're just testing those two functions. So that's yeah, tests. Tests are a big part of the smart contract world. How to make a bid on a Stellar smart contract auction. I basically took some code of an auction and I tweaked it, and then I started to deploy it and test it. So one of the things I found on the Stellar website took me to a link to some videos. One of the things was so if you one of the things was actually using aliases, which I'll talk about in a second. But yeah, if you are doing some testing, you will need to fund your user's account if you want to actually simulate doing an auction or making a bid. You have to have some test lumens, which is the Stellar currency. So here I was doing Stellar contract deploy. So you'll typically always, if you're working with smart contracts in Stellar, typically it'd be Stellar contract and then deploy, invoke, and so on. If you want to build the contract, it's Stellar contract build. The Wasm, so Wasm is the path. If you've got that autocomplete set up on your terminal. So let me just show you that. Rather than test it or copy and paste it and so on, if we go, I don't know if this is a compile, might have to Stellar contracts. Let me just clear that so it goes top of the screen. Right, Stellar contracts build. Okay, that built. So then we do Stellar contracts deploy. And then it says it wants a source account. So then we do, I've set up, so you'll see the examples of Alice everywhere and Alice and Bob. You do have to set those as environment variables. So depending on, it'll be different whether you're on Windows, Linux, Mac, or whatever. But yeah, just look up setting environment variables. So then I've generated an Alice key pair and then set that to my environment variable. So wherever I use Alice, it obviously uses that. So this is where I was getting to. And if you do --wasm and then tab, gives me points, which is my current subdirectory. But if I go up one, there we go. So you do // press tab, and you don't do /tab, you do // t lowercase for target, then keep going. So then press tab again, press W, press tab again, R for release, press tab again, points, Wasm. So it saves you typing it from scratch or copying and pasting it in. I know I've made a meal of that, but it is pretty quick. Like if I do it from scratch, like okay, ../t Wasm release points Wasm, and then you need the network. So again, I've set that in my as an environment variable. So when I do -- network and type testnet, testnet actually has the details for the full testnet. And this should take 5 seconds approximately. It's missing argument admin. That's because, so this is where you have fun. So once you get into the arguments, you do -- and then a space. There we go, usage constructor. What's going on here then? So this is where you have lots of fun. So you do -- let's do -- help. Okay, so we need to do _ constructor. Unexpected argument found. Let's go right back. So missing argument admin. Sorry, I know. So I need the double hyphen, then a space, then double hyphens again. There we go. So now you can see we've got admin, then space address. So rather than doing address, I'm just going to, rather than actually paste in a full address, I could just type Alice, because Alice is the same as putting in an address. There we go. So now we've got a link there, which is stellar. So if we open that link, you can see the contract that we've just deployed with constructor. So because I used a constructor, I needed to pass in admin Alice. So that's what you get because you use the constructor. If I didn't use the constructor, I wouldn't have had to have added that. So just remember, it's -- space, and then -- admin, then space, and then Alice. So yeah, if we come here, you can see the interface. And those are the functions that I had in the code that we looked at. So that's the constructor. Set, get, add points, unions. Okay, so it's calling the enum a union. I can't comment on that. If you want to download your Wasm code, you can do that. Here it's going to open it in text editor. So that's your Wasm. That file is pretty small typically. Data storage. Home domain over cat.me. I don't know. I think I added that somewhere. So that's all your history of all your transactions. And that's your account balance. It's all the test network. So that's the public network, which is actually worth money and convertible to money. So there you've got XLM up 1%. That's all the other assets, and you can convert them between each other. So you have to set up like a path, and then you can send between each one. So you could send but Alice could send Bob some XLM. Bob could send some Bitcoin to Carol, and then Carol could keep the Bitcoin and then send some XLM to Dave. So it's basically a series of transactions where the end-to-end payment is Alice sending Dave some XLM, but people in the middle can use a different currency. So I'm just talking, I'm kind of freewheeling a bit here on what I've learned recently, but one of the important tips, I mentioned it the other day, is actually using, yeah, make sure you fund your users. If you don't, you get some really odd errors, and it's not obvious at first what the error is. Yeah, diagnostic event. You'll get a diagnostic event and you won't know what the reason is. You have to fund your account. Look up funding your account on Stella. There's plenty of info out there. So yeah, the auction that I did, I had initialize, bid, end auction, get auction details. If you want the code, it's I think I put a link to it here. I can't remember, but yeah, librs. So we're going to look at the code for the auction. So again, similar pattern. So I'm trying to kind of take away the mystique a bit here. So again, you've got all your imports. You always have contracts import, and then if you're adding an enums are really useful because it forces you to use a specific value or key value pair. The value is actually, if you use the auction error, which is part of contract error, then you have to have a number. But if you were just using a normal enum, you wouldn't need that bit there. So auction ended, bid too low, not auction owner, auction not ended. You got a struct here, which is item owner highest bidder, end time is active. This is the contract, so you've got initialize. That starts the auction. Note here we're using bytes for there. I'm not sure if that's the best way. I think I copied and pasted this from an example. I would probably go back and set auction as a constant. See there and also there. If you set it as a constant, then it's better. And then you've got some, just run through the logic. So if the current time is greater than the auction end time, then basically the auction's ended. If the amount is less than the auction's highest bid, then the bid's too low. So there's some logic to get your head around here as well. So there's kind of like the code and the syntax, but also the overall picture, which is the logic of the contract. And that's kind of what I was alluding to when I was kind of saying don't over focus on what blockchain you're using. As long as you're learning some Rust and you're learning some programming logic, don't get too dependent on the particular framework or the particular blockchain. So end auction, if caller is not the auction owner, so you've got to be the owner of the auction to end the auction. If the current time, auction not ended. If the current time is less than the auction end time, you can't end it. So you can't end the auction early. Using clone there because we want to use winner down here. So often you'll get stuff that implements clone, but it doesn't implement copy. There's no such thing as the heap really with smart contracts. There's something called alloc, but everything's linear memory. So the stack and heap paradigm is not probably what you need to be thinking about. So that's my auction contract. And if you want to see some other stuff, I've done voting, loyalty smart contract, voting, and I did an auction, and I didn't. So I've had a couple of goes at voting. So the voting, the difficult thing on the voting would actually be to ensure that nobody can vote twice. So you'd probably have to do, I don't know, but you'd probably have to do some sort of multi-factor authentication, something like that. So lib.rs, voting contract. This is a bit more basic. So you've got um, create proposal. So that's basically what the name of the options are. So that you'd call that sort of, you know, general election or presidential election. And then you could have yes votes, no votes. Or you could have turkeys voting for Christmas, and then you could have yes and no. And you got vote yes, vote no, and then you got get results down here. I had to on this. I had to turn off snake case because I was getting warning messages with using none. So you're still using the standard get here, which returns some or none. So this is still standard. This is still Rust. So you need to then just get the value out of the option, which can be some or none. And then you return in a tuple here, yes and no votes. So that's where you specify what you're sending back. Yeah, there you go. Thanks for watching. Catch you soon.